Hey guys, and welcome back. Let's go ahead and get the software installed to configure Kubeadm on these two virtual machines. So I'm going to head over to the Kubernetes documentation here, and we're going to follow the directions for installing Kubeadm. Now, one of the things that we're going to need to install on both of these virtual machines is the Docker engine. And the Docker engine is what we're going to use as the container runtime, which is right here under the installing a runtime section. So let's go ahead and do that on each of these. So I'll do a sudo apt update and sudo apt install docker.io --yes. And I'll go ahead and just copy that to my clipboard and run that. And then I'll paste it on the second node as well so that we can get the Docker runtime installed on both of these nodes. Now, while that's happening, we can go ahead and take a look at one of the other steps here, which is to enable some IP tables rules here. So I'm going to go ahead and copy this script here to my clipboard, and we're going to run that on both of these nodes as well, just to ensure that IP tables is configured correctly. So on cbt master 01, we'll go ahead and paste that in and run it once Docker gets installed here. Give this a second to finish. And we'll go ahead and right-click and paste that in. And it looks like this command on the other node, it didn't quite copy correctly. So let me just paste that in one more time here. We'll do a sudo apt install docker.io --yes. And then we'll go ahead, so this script over here, we'll go ahead and paste in and run it. And as you can see, we've updated our IP tables configuration here. And then we'll do the same thing on node number 2 once it's finished installing the Docker engine. All right, so we'll paste this in. Oh, let me go ahead and actually copy that back to my clipboard here. And we'll paste that in and run that configuration script. And so now we've got IP tables configured on both nodes. Now, one of the other things that we need to do as well is to configure the Docker engine so that it uses the systemd cgroup fs. So I'm going to go ahead and just search for cgroup fs Docker here. And there's a great article here on Stack Overflow that actually describes how you can reconfigure the Docker engine. And we're going to do that using the native cgroup driver option on the Docker engine. So what we need to do is actually edit the systemd unit file for the Docker service to ensure that we can use the cgroup driver of systemd instead of the default. So let's head back over to our terminal here. And if I just do a sudo docker info on one of these nodes in our cluster here, you can see that our cgroup driver is currently set to cgroup fs, and we want to change that to use systemd instead, which is the preferred option for Kubernetes. So I'm going to do sudo vim, let's do lib systemd /system/docker.service, and we'll go ahead and just edit that file. And then down here on the line where it says exec start, we're going to go ahead and add in an option here. So we'll paste in this option, exec opt native.cgroup driver equals systemd. And then we'll save this. And we'll do a sudo systemctl daemon reload. And then we'll go ahead and do a sudo systemctl restart on the docker.service. And now, if we rerun the command to do sudo docker info, we should see that the cgroup driver has been changed to systemd. So we need to do this same thing on our secondary node here as well. Let's do sudo vim lib systemd /system/docker.service. And then on the exec start line here, I'll go ahead and add in this option here, and we'll save that. We'll do a sudo systemctl daemon reload, and then we'll do a systemctl restart on docker.service, and then we'll just verify this by doing sudo docker info, and it should be configured to use systemd. Awesome. So now that we've got the Docker CRI set up, we can go ahead and proceed on to our next step. So let's get Kubeadm itself installed on our dev systems here. So I'm going to head back over to my browser and take a look at the installing Kubeadm documentation. And we are going to take a look at installing Kubeadm, kubelet, and kubectl itself. So we're going to run these commands on each of our virtual machines to install from the apt repositories. So I'm going to go ahead and run this on both of my nodes here. We'll do a sudo apt update, and we'll install a couple of dependencies here. And then once we've done that, we can go ahead and download the Google Cloud public signing key. So I'll run that on both of my nodes as well. And then once we've done that, we can go ahead and add the Kubernetes apt repository. So we'll do that on both of our nodes here. And then once that's done, we can go ahead and run a sudo apt update again and install all of the necessary utilities on both of these virtual machines. So we're going to be installing kubelet, Kubeadm, as well as kubectl. And then once both of these nodes have been set up, we can go ahead and initialize our new cluster. All right, so both nodes are set up now. We've got all of the necessary utilities installed, like kubectl and the kubelet and Kubeadm itself. So if I were to run sudo kubeadm here, you should see that we're able to run that successfully. And we can see all of the different subcommands that are available. Now, if you recall, before we get too far ahead of ourselves, we are going to be putting a load balancer in front of our Kubernetes master nodes to ensure that we have high availability. So if we were to take a look at the documentation for Kubernetes and take a look at the creating highly available clusters, one of the things that they will actually have you do is to actually create a load balancer so that the load balancer can serve as the communications endpoint for the cluster. So before we actually initialize the cluster, we need to go ahead and create a load balancer to serve as the cluster endpoint. So we'll do that in the next video. I hope this has been informative for you, and I'd like to thank you for viewing.